A commercial drone is a small unmanned aircraft with an onboard camera. It can capture a bird's eye view of the ground, collecting up-to-the-minute data useful for many types of applications. They're used to plan infrastructure projects, oversee natural resources, and manage farmland. Spanning about 5 feet in diameter, this commercial drone is also known as an octocopter. It has 8 rotors which enable it to maneuver in the air like a helicopter. The drone's components are made of carbon fiber, a highly stiff, strong, and durable material. Carbon fiber is also lightweight, a critical factor in aviation. Computer-guided milling machine cuts the parts. A technician manually sands their edges smooth. This component makes up half of one of the drone's legs. The mill cuts out the top and bottom frames for the drone's body. Technicians then assemble the 2 halves of each leg. Some of the drone's components are produced by a 3D printer. The printer builds each part, layer by layer, out of a thin stream of plastic. This is one of the drone's 8 arm receptacles. A technician drills a hole where the arm will be fitted. The hole must be precise to ensure a secure fit. After verifying its diameter with digital calipers, the technician installs the back part of the receptacle and the lever that clamps the inserted arm firmly in place. He attaches an electronic speed controller to one end. Then he screws the receptacle to the bottom frame of the drone's body. The wires coming out the other end of the controller connect to an electrical power harness and to the autopilot. The autopilot is the onboard computer that runs the drone. He installs the 7 remaining receptacles, then the power harness. It has 8 connectors, 1 for each electronic speed controller. Next, he attaches the top frame. Then the payload mount that holds the camera and hard drive. He links the payload mount to a servo motor, which is guided by the autopilot. The drone's body is protected by a cover. Workers mount a sheet of plastic on a vacuum former machine. They start up the machine's heating element and position the plastic just beneath it. This gradually heats the plastic to a malleable state. Once the plastic is soft, they position a wooden mold on the machine. Activate the suction, then drop the sheet onto the mold. The vacuum draws the plastic tightly against it. They let the vacuum-formed plastic cool and harden. Then carefully trim off the excess. They cut out a rough opening for the payload mount. Through that opening, they secure the cover to the computer-guided milling machine, which finalizes the shape to precise specifications. Once the cover is finished, they install it on the top frame. They attach the 4 legs to the bottom frame. Then they install the camera onto the payload mount. The mount pivots to angle the camera at the ground. They insert and clamp the arms into the receptacles. Each arm is a carbon fiber tube with a plastic rotor that's driven by a small motor underneath. Upon inserting an arm, its motor makes contact with its electronic speed controller. They also install the autopilot. The autopilot executes the programmed flight path and operates the camera, the servo motor that moves the payload, and the electronic speed controllers. The drone operator can communicate wirelessly with the autopilot using a remote control. But it's more common to program the GPS coordinates of the drone's route prior to takeoff.